Welcome to Lesson 1 of the Kubernetes Beginner's Guide. Let's start where every real engineer starts, the architecture. Every kubectl command you'll ever run is just an HTTP request that travels a path. API server, etcd, controllers, scheduler, kubelet, container. 6 processes split across a control plane that thinks and a data plane that acts, the brain and the muscle. Master who does what and what happens when each one dies, and the next 11 lessons click into place. So here's the loop you'll walk by the end of this lesson. The same SRE cycle you'd run on any production system, applied to the cluster itself. First, observe. Name every component, control plane, and node, and know whether it's a pod, a systemed unit, or a static pod. Then diagnose. Who does what? Because that's the primitive every debug session starts from. Then act with a runbook per failure mode. API server down means the cluster goes blind, etcd loses quorum and everything freezes, kubelet dies and the node goes not ready. And finally, document the full request path end-to-end, kubectl to apiserver, to etcd to scheduler, to kubelet to runtime, to kube-proxy. That trace is the senior reflex we're installing today. And the foundation of that whole map is this one split, control plane versus data plane. The control plane is the brain, API server as the REST gateway, etcd holding state, scheduler placing pods, the controller managers reconciling toward what you asked for, plus the cloud controller talking to your provider. The data plane is the muscle on every worker, kubelet driving the node, the container runtime actually running containers, kube-proxy, and the CNI wiring the network, and your pods riding on top. Brain decides, muscle executes. Internalize that, and every component we name from here on snaps into place. Let's zoom into the brain. 4 of these 5 components are stateless: API server, scheduler, controller manager, cloud controller, and the 5th, etcd, is where all the state actually lives. They never gossip directly. Every conversation goes through the API server. And the diagnostic trick is simple. Learn what each one does, and you immediately know what breaks when it dies. API server down, kubectl goes blind but pods keep running, etcd loses quorum, the whole cluster freezes. Scheduler dies, new pods sit in pending while existing ones don't care. Controller manager dies, nothing reconciles. Deployments stall, dead nodes never get evicted. One job each, one failure mode each. Now drop down to the muscle. Every worker node, and every master node too, by the way, runs the same 3 things. Kubelet is the agent, a systemed unit, not a pod, watching the API server for work assigned to it, pulling images, starting containers, running health probes. Kill it, and the node goes not ready in 40 seconds, with pods evicted after 5 minutes. Kube-proxy programs the network, IP tables or IPVS rules that make cluster IP virtual IPs actually route somewhere. When it dies, rules go stale and service routing rots gradually. And the container runtime, containered or CRIO, is what actually runs your containers. Lose it and kubelet has nothing to talk to. Notice the pattern. None of them talk to each other. They all watch the API server. That's the loose coupling that makes Kubernetes survivable. So let's put it all in motion. You type kubectl apply, and here's the 7-step dance that follows. Kubectl reads your kube-config and fires a post at the API server with a bearer token. API server runs authentication, then RBAC, then mutating and validating webhooks, then writes the deployment to etcd. The controller manager wakes up, creates a replica set, which creates pod objects with no node assigned. Scheduler picks a node and patches spec.nodename. Kubelet on that node sees the assignment, pulls the image via CRI, starts the container, and reports back. 5 components, 1 request path, and every failure mode you'll ever debug lives somewhere on this line. Now, a fair question. If the API server runs as a pod, Who starts the API server? That's where static pods come in. Kubelet watches, etc. Kubernetes manifests on each control plane node and runs whatever YAML it finds there directly. No API server, no scheduler involved. That's how etcd, API server, scheduler, and controller manager bootstrap themselves. Everything else you rely on, core DNS for service discovery, a CNI like Calico for pod networking, metric server, ingress controllers, those are normal deployments in kube system. Core versus add-on. When DNS breaks, you debug core DNS, not the API server. So let's turn all of this into reflexes you can actually use. 6 habits that separate someone who memorized kubectl from someone who operates a cluster. Trace the request path. Kubectl times out means API server. Pod pending means scheduler. Stuck pulling means kubelet. The component is the diagnostic. Snapshot health with kubectl get, raw, lives. When the API is down, SSH in and read var log pods directly. Remember, API server is the only API, everything else just watches it. Static pods solve the Bootstrap chicken and egg, and treat etcd as sacred. Back it up, because etcd is the cluster. And here's the whole lesson on one page. A cheat sheet to pin somewhere visible. Top row is the control plane brain. API server as the REST gateway, etcd as the state store, scheduler placing pods. Middle rows are the muscle, controller manager reconciling, kubelet running the node, kube-proxy wiring IP tables, containered executing containers, static pods bootstrapping the whole thing. Bottom row is your diagnostic toolkit, lives for API health, etcd snapshot for backup, journal Clio for kubelet logs. 12 patterns. Learn these names, and the rest of the course clicks into place. Before we close, 5 traps that quietly double your learning curve. 1. There is no master binary. The control plane is 5 processes that fail independently. 2. Kubelet isn't a pod. It's the system unit that runs pods. 3. Components don't talk to each other. They all watch API server. 4. etcd isn't just a database. It's a raft cluster with real operational rules. And 5, CRI, OCI, and CNI aren't trivia. They're the seams where Kubernetes plugs into everything else. Skip these traps, and the next 11 lessons compound. Now, theory only sticks once your hands hurt a little. So 3 exercises on the local cluster from lesson 0. First, map your control plane. List the kube system pods, describe each one, and draw the architecture on paper. Second, kill kubelet on a node and watch it go not ready in 40 seconds. Pods evicted at 5 minutes. Those 2 timers are the blast radius every SRE memorizes. Third, open 4 terminals and trace a pod creation live. Apply events, pods, and the kubelet journal side by side. 60 seconds, all 5 components doing their jobs in sequence. Do these once, and the next 11 lessons land on real muscle memory. And that's lesson 1 in the bag. 5 control plane components, 3 on the data plane, the request path traced end to end, and static pods demystified. That's your map. Next up, kubectl and cluster bootstrap. We'll get Minikube, Kind, and K3s spinning, untangle kube-config and contexts, and walk through RBAC so you can switch between clusters without breaking a sweat. See you in lesson 2.